Alright, this video is going to be pretty short because we only had a couple examples that we did not get to cover in class, so we'll go ahead and do those now. You'll find those at the end of your PowerPoint if you print those off of My Math Lab. So sometimes we get an equation that it doesn't appear that we could solve it quadratically because it doesn't at first appear to be quadratic, but if we rewrite it using an algebraic expression such as the one you see here with the u's, then we can. And so we're going to go through a couple examples like this. Alright, so here's this example. We have the quantity x plus 1 to the 2/3 power minus the quantity x plus 1 to the 1/3 power minus 2 equals 0. And so upon first look we would think, how would I ever solve that? But what we can do is take this middle expression and do a little something with that to help us to make it quadratic in form. And as a rule of thumb, generally it's always this middle expression. And so what we're going to do is we're going to take that and let that be our u. So we're going to say let u equal x plus 1 to the 1/3. And now what I can do is rewrite this equation like this. This first expression here, or term I should say, becomes u squared. So I have u squared minus u minus 2 equals 0. And I can do that because if I take x plus 1 to the 1/3 power and square it, then I get this expression. So now I have this, which is a simple quadratic. I can easily factor it. And so I can factor it into the following two factors. So I have my two factors here, u minus 2 and u plus 1 equals 0. And now I'm going to take each of those factors and set them equal to 0. That's a zero factor property which we've been using, and solve for u. So u is going to be equal to 2 and u is going to be equal to -1. And now normally that would be where we would stop when we're solving a quadratic equation, but we remember we've replaced something with this u, and so I've got to go back and take that and substitute it in for my u's and continue to solve for x, because I'm trying to find x, not just u. So I'm going to do that at this time. We're going to take x plus 1 quantity to the 1/3 and substitute it in for each of our u's, and then solve for x. Okay, so here we have x plus 1 to the 1/3 equals 2, and x plus 1 to the 1/3 equals -1. And now I'm just going to solve each of these equations. Okay, now, in order to do that, I'm just going to raise each side to the reciprocal power. And so x plus 1 quantity to the 1/3, I'm going to raise to the 3rd, and whatever I do to one side of the equation, I have to do the other. Okay, so over here, again, I've taken this term and raised it to the 3rd, because in rules of exponents, a power to a power, when you multiply, I would get 1. And so I'm left with x plus 1 here equals 8. And on this one, I would be left with x plus 1 equals -1. And then I just continue to solve, so I get x equals 7 and x equals -2. And those will represent my final two solutions to this quadratic. And this will be another example of the same type of problem, these negative exponents, but it is quadratic in form. And so again, we're going to take this middle term, and that is going to be what we're going to let u represent. So let u equal x to the -1. And so then we're going to rewrite our equation replacing both the x to the -1 and the x to the -2. And so we're going to get 6u squared plus u equals 2. And then I'm going to move forward with solving this equation for u first, and then of course going back and replacing and solving for x. And so first we would need to, since it is quadratic, move everything to the left hand side. So we get 6u squared plus u minus 2 equals 0. And then I can do a couple of things at this point. I can either factor to solve, or I can use quadratic formula. And I'm going to factor this one to solve because it is easily factored. I do have to consider this leading coefficient here, and since it's not a 1, I am going to have to split the middle term. So I need to split the middle term in order to have two numbers that multiply to negative 12 but add to a positive 1. And the two numbers that do that for me are negative 3 and positive 4. So I split my middle term into negative 3u and 4u, and now I'm going to factor by grouping. So I take out a 3u here, and I get 2u minus 1. And then I'm going to take out on the other two terms a positive 2, and I'm going to get 2u minus 1. Therefore, my two factors are going to be 3u plus 2 and 2u minus 1. And now I take each of those, set them equal to 0 to find out what u is equal to. So here are my two factors equal to 0. That means u is equal to negative 2/3 and u is equal to 1/2. And so now what I need to do is go and take back and replace my u with whatever I let it be equal to. And in this case, I let it be equal to x to the negative 1. So I have x to the negative 1 equals negative 2/3, and x to the negative 1 equals 1/2. And now, x to the negative 1 is just the reciprocal of x. So if I take the reciprocal of this side and reciprocal of this side, I'll have my solutions. I have x equals negative 3/2 and x equals positive 2. This last example is not one that incorporates the use of a u. We kind of use this technique that we're going to use here in the first example towards the end, but since I have this whole quantity over here raised to the 1/4 power, in order to get rid of this little power, I'm going to raise each side to the reciprocal of that power, which is 4. And so again, by doing that, 1/4 to the 4th becomes 1. And so I'm left with 5x squared minus 6 equals x to the 4th. And so now I'm going to move everything to the right-hand side because I want to keep my x to the 4th positive. And so it's going to become 0 equals x to the 4th minus 5x squared plus 6. And now at this point you could incorporate the use of the u and let u be x squared. Therefore this would become u squared. But you could also solve this one just by factoring. And I'll show you that way now. 0 would become 0 equals, and this would be x squared and x squared, much like x and x when we do it. And now I need two numbers that multiply to 6 but add to negative 5. And so that would be a negative 3 and a negative 2. And then from this point we could solve this equation. And so we have 0 equals x squared minus 3 and 0 equals x squared minus 2. And then this would become 3 equals x squared and 2 equals x squared, taking the square root of each side, plus or minus root 3 equals x, and plus or minus root 2 equals x. And these would be my two solutions. If you would like to see this equation solved using the u method that we used on the previous two examples, then you may look that up on the PowerPoint. It's on slides 58, 59, and 60. And this will conclude section 1.6 that we didn't get through with in class the last time we met.